Hi, welcome to this video. Today we want to look at what functions and relations are. This is not a cooking video now. I just want to use this as, some model so that we might understand better what functions and relations are. So the strawberries we have right here on the left, I will call that our input because of course we'll put that into the blender. Okay, so the blender will call it, let's just call it our engine, okay? Just bear with me for a moment. And then this one, I'll call that our output, okay? Our output. So if say I've got an input of 2, and then, our output gives us maybe a 4. And then let's say, using that same engine that, churns out 4, let's say the next one is an input of maybe 4. And let's say our output is 6. You might begin to wonder then that the particular engine we're using here is taking all our inputs, okay, and adding 2. And that gives us the output. Okay, now if we have this, right, and we call all the inputs say X and all the outputs say Y, output equals to input plus 2. All right, now if I then decide, to pick this in pairs, so for instance, I pick my input, which is 2, right? And then because of this particular engine, I have to pair 2 with 4, right? And then I pick 4, and then I pair it with 6, and I put this in a set, like so. You will call this a relation, okay? So a relation could also be a function, but not all functions are relations, so how do you then define relations? Say you decide to define it. Obviously, you will say a relation is a collection, of ordered pairs. Or you could say a relation is a set of ordered pairs. A relation is a collection of ordered pairs. A relation is a set of ordered pairs. Okay, so I'm going to write that down now and, just take a look at the terminology, so, okay, so a relation is a set of ordered pairs. Now, let's take a look at some of these terminologies, When we say it's a set, remember that I had to collect these into curly brackets, So that tells you it's a set because I've grouped them together, Why do we then say that they are ordered? They say that so you know that this first one is your input, which is your X, remember? And then this 4 is the particular output that corresponds to this input, okay? So you cannot interchange inputs to your output. So you can't write this as 4 and 2 and expect that they mean the same thing. They will mean things, they will mean different things because you've switched to your input of 4 and an output of 2. That's totally different because it's the engine that will churn that out will be totally different. Okay, so now that we know what the relation is, I just need to show you some other terminologies that are important here. All these sets of your inputs are called together, you call them the domain. And all the sets of your outputs, you call them the range. And sometimes you call the range the image set. Okay, now why is it called the image set? Obviously, you see that the inputs have looked at themselves in a mirror, okay, and they've churned out the image. So the image set, if that makes sense. I hope we understand what the relation is now. We've also looked at what the domain will be and what the range will be. Now, don't go away, because at the end of this video, I intend to at least give you 10 examples that would make your knowledge really grounded on what an input and an output is, what a function is. The next thing we want to do is to explain when a relation is a function, because this doesn't happen always, okay? When is a relation a function? Okay, so imagine that you arrive at this road. Where do you go? Left or right? Okay, so this is how it feels when an input goes. Okay, so let me put this as your input. Okay, and let's say the engine is right here. Okay, and let's call this an output here and then an output here, right? So this is how it feels when you have your inputs, arrives at the engine, and then you've got two outputs. Where am I supposed to go? Are you going to the left or to the right? Yeah, so any engine, okay, that has the same input giving you two or more outputs is not a function, because easily the input is going to be confused. Where is it going to go? Left or right? Okay, this is very important. Now let's take some examples to show you what I mean. Yeah? Right. So here, let's say is an input, okay? And then you've got the engine, and then you've got the output. Okay, so let's say what you have here are 8 and 3. And then say 8 goes and gives you 10. But then 3 goes, okay, gives you 4. And the same 3 goes, gives you 5. Whatever is in here, okay, we haven't put anything there, but whatever is there is not a function. Not a function, okay? Let's take an example that will show us, some things that are not a function. Yeah. You remember that we could call it a relation, because we could say, okay, 8 gives 10. Yeah. We could say 3 gives 4. And we could also say that 3 gives 5. Yeah. So if we put this in a set, this is a relation. Okay. But not a function. Okay, a relation, not a function. Right, so let's take proper examples now, yeah? So for the very first example, we want to see, an example of an engine. Yeah, that is not a function. So let's say this is my engine, and these are my inputs, and here are my outputs. Now, as my engine, I would consider x squared plus y squared equals to 1. Yeah, this equation is the equation of a unit circle. A unit circle, yeah. So a unit circle has a radius of 1. All right, so, this particular formula, for those who are familiar with it, it's not very important right now, is x squared plus y squared equals to r squared. So this is 1 because 1 squared is 1. Yeah, okay, so say, for this particular function, I use an input of, because it's a unit circle, I can't go beyond 1. So let's say I use an input of half, right? That's a single input. Yeah, let's take a look at what output is going to give us, okay? So if x is half, I then have half squared, right? Because this is the engine doing its work now, plus y squared equals to 1. And some little algebra will tell you that y will be equal to plus or minus, is it the root of 3 over 2? The root of 3 over 2. Okay. All you need to do is to square this, which gives you 1 over 4. Take that to the other side, which gives you y squared equal to 1 minus 1 over 4. That gives you y squared to be equal to 3 over 4. And if you take the square root of both sides, you have y to be plus or minus 3 root 3 over 2. Okay, why it's plus or minus is simple. If you pick the positive of root 3 over 2 and you square it, you will get 3 over 4. Likewise, if you pick the negative of 3 over 2 and you square it, you will still get, this is a root, you will still get 3 over 4. Yeah, so when you are going backwards this way, you say y is plus or minus root 3 over 2. I hope that makes sense. Okay, so here you've got root 3 over 2, that's the positive part. And here you've got negative root 3 over 2. So yeah, half is left asking itself, do you want me to go to root 3 over 2? Or, for the life of me, do you want me to go to negative 3 over 2? When this happens, you say that x squared plus y squared equals 1 is not a function, okay? Just something else that, will help you to know if, an engine is a function. Let me show you that quickly, and, that will be the graph of x squared plus y squared equals to 1. That's the unit circle, all right? Just let me clear this a little bit and then plot the graph. Okay, so what I've done here is to plot the graph of y squared plus x squared equals to 1. That's your y-axis, and this is your x-axis, okay? Now, remember that the input was half, so this is half right there, okay? And what you normally will do is to trace this, to the circumference of the circle. And then what you want to do is to also trace that to the y-axis, okay? So here are 2 points where there is an intersection. Here, let's call it, if you like, the point B. And obviously the x value for point B is 0.5. So let's say that this is point A, and obviously the x value is also 0.5. What are the y values? Remember that we will be tracing it down here, okay? And if you look closely, that will be, if you like, our root of 3 over 2. And if you trace this down, this will be right there. That place there will be negative root 3 over 2. You might want to use your calculator to verify that. Okay, so for the first one, we have root 3 over 2. And for the second one, we have negative root 3 over 2. Okay, so this is what I wanted to point out, because what this has shown is what I've talked about earlier. But what makes this different is that we are now relating it to graphs. So on your graphs, if you draw a vertical line and you find that it crosses your curve at 2 or more points, then you tell yourself that that function, that, engine, in this case, this curve, is not a function. So this, vertical line is called the vertical line test when you're using it to determine whether, something is a function or not, okay? So remember that when you have the graph of a function and you use the vertical line test, okay, to test vertical line test, you use this to test to see if it's a function or not. And if your vertical line crosses your curve at 2 or more points, you know that that is not a function. I mean, that's how easy and how cool is that? Really, really easy and really cool. So here we are. I think it's time to show you those 10 examples I was talking about, yeah? Okay, so let's begin. We begin with this graph. I mean, just by looking at it, you can easily tell that this is a function, yeah? There's no way you draw vertical lines here that is going to cross the curve at 2 points, okay? So if you draw a vertical line and you see that it crosses your graph at only 1 point, then, that's a function. Yeah, just for you to know, this graph is a graph of y equals to cos 2x, yeah, plus sine 2x. Yeah, let's take a look at number 2. And for number 2, I've got a number of relations. Okay, so let's look at the first relation. 9, 13. Okay, 320 and negative 11, 13. Now, to try to understand it, like I've shown you, it might be better to draw a diagram, yeah? So that we can put in what the inputs are. We probably don't need the engine, but we need the outputs. So what are the inputs? You've got 9, you've got 3, and you've got negative 11. What does 9 map into? 9 maps into 13. So can we put 13 here? And then 3 maps into 20, okay? And then we know that negative 11 maps into 13. Oh, okay. So because we already have a 13 up here, to see it properly, it's probably better we don't draw another one down here, okay? So what we'll be doing will be to link this to 13. Now, this may be confusing, but it should not, okay? 9 is not confused as to where to go. He knows he's got only 13. Negative 11 is not confused, as a way to go because it's got 13, only 13. So yes, this is a function. Gone. Okay, so let's look at this relation. You've got 20, negative 13, 16, 4, okay, 20, 17, and 13, 7. No, 13, 17. There you go, okay? I'm just going to put this in curly brackets. And then you have that, okay? So again, let's draw a diagram. This is not important for exams, by the way. This is just to help us, follow through with what we've started to model, just for your understanding, okay? So you've got 20 right there. So it's just one is enough. You've got 16, and then you've got 13. So 20 maps into negative 13. 16 maps into 4. And then 13 maps into 17. The first 20 maps into 13. And then another 20 will map into 17. Okay, so yeah, that's what we have. And, obviously this 20 will be the confused one. Oh gosh, where am I supposed to go to? He's got no clue. Should I go into negative 13 or 17? And because this is happening, we say that whatever is the engine here is not a function. Pretty clear, isn't it? Right. So, how many more examples to go? 8 more examples to go. I did 2 in 1 here, by the way. Yeah? But we have 8 more examples to go. So, let's, try to pick up the next one very quickly. So, the next one is x equals y to the power of 2. Is this a function? Well, the answer is no. And one way to find out if that is true is to plot the graph. But that's not the only way. So I'm going to plot the graph. Okay, well, I think I should better say sketch. I'm going to sketch the graph. And then I'm also going to, use algebra, if you like. So yeah, the graph of this will look like this. Now, just check online to see, if that is the case. So you have x equals to y squared. This place should be curved. It's a bit sharp. So yeah, your y-axis and your x-axis. Now this very much fails the vertical line test because I draw a vertical line and it crosses this graph at 2 points. Hence, it's not a function. What other ways would I use to find out? Well, one way could be to look for inputs and then to look for outputs. So if I have an input, and then of course the engine is x equals to y squared, and then I have an output, what would this look like? Yeah, okay, so you've got, let's say I put in 4 here, okay, and of course the engine is x equals to y squared. Okay, and these are my x's, which we call our domain. Remember, domain, yeah? And then, these are y's, which we call our range. Yeah, so if you put 4 in for x, remember, and then you will get y to be plus or minus 2. So you have 2 and you have minus 2. Hence, this is not a function because, there are two different outputs for the same input. So that defeats the definition of a function. All right, shall we quickly go to example 4, I think? Yeah, let's do that. Okay, what I have here is an ellipse. Okay. The equation is x squared over 16 plus y squared over 4 equals to 1. All right, remember this is your y axis and this is your x. Obviously, this, fails the vertical line test. So when you see this, just note that that is not a function. Okay, so let's go to the next example. Okay, so next example I'll give will be y equals to x cubed. Okay, obviously if you sketch this, you probably get something that goes this way. And yeah, I've probably not drawn that well, but yeah, basically it's going to go that way. Yeah, and this will definitely pass the vertical line test. So this is a function, right? Yes. We go to the next example, and this particular one, it might be good to look at what the parent function looks like. What we call the parent function is just the function, like the most basic category of this function where no transformation has been put into it. The most basic of this is just y equals to x squared. Yeah, so before the 1 over 10 and the negative comes into it. Yeah. So if you want to, what we're looking for is just to consider whether this is a function or not. And this sketching of the graph definitely helps us to determine if that is the case. So why don't we look at how to sketch what this graph is? Okay. So we should have the y-axis there and then the x-axis if you like. So again, the most basic function, we just y equals to x squared, the parent function, we just go this way. Okay, we probably don't need to worry about the 1 over 10 because what that does is just to make it a bit wider. It climbs up a bit slower than normal, because whatever your x squared gives you, 1 over 10 just kind of reduces that, so it makes it climb up slowly. Okay, so this is y equals to, say, 1 over 10 x squared. Now the negative function here just reflects it in the x-axis so that your graph, instead of being up there, comes down here. So it's completely negative, so it's below the x-axis this time. Yeah, so this is what it looks like. Okay, so now we have the graph we are looking for. So this is y equals to negative 1 over 10 x squared. And the question is this a function? And of course the answer will be what? Yes, it is a function, because if we draw a vertical line, you see that it will cross the graph at only a single point. So that makes it a function. Okay, we quickly go to the next example. Okay, let me see if I'll find it here. Here it is. Okay, this one is very easy because if you sketch this line, it's a straight line, and straight lines are functions, and there is really nothing to be said about it. If you want to consider how to sketch it, however, I'm just going to quickly do it. Okay, the most basic function here will be y equals to x as a parent function, which typically travels this way. Okay, now if you add 1, it means it's going to skip up 1 space. So you have something that looks like this. Okay, and here will be 1. Yeah. When y is 0, and here will be -1. So now I have this 1 will be y equals to x. This is y equals to x plus 1. And just as we said, this negative reflects it in the x-axis. Okay, so we are going to reflect this line in the x-axis. If you do that, this part bounces back up. I like to use maybe another color for that one. Hopefully it's going to let me pick another color. Yeah, let's see. Okay. Well, it doesn't let me pick it, so I'm just going to continue. So this part here bounces back up, and you have that. This part here obviously will go down. So you have this, okay, and yeah, it's just going to continue that way down. So what I've done is to reflect that in the x-axis to give this part, and this part I've reflected it in the x-axis to give this part. Okay, so I'm just going to clean this one and take it away. This one we have will then be y equals to -x plus 1. Okay, in that case, this one will be -1, right? So I'm just going to clean this one out and take this one out and take this one out. So as you can see, a vertical line, okay, never crosses your function at any 2 points. So this is also a function. I promised I was going to give you 10 examples, and I suppose we should be on the 6th one. I don't know. I've kind of lost count, so I will do 4 more, and then I will have fulfilled my promise. Okay, so on to the next one. And for this one, you can see that the graph also will not be a function because of the way it's sketched. If you draw a straight line, it crosses the graph at 2 possible points. And because of that, it won't be a function. Well, if you are worried about how to sketch this graph, I will leave a link after this video that also talks about how to sketch graphs, straight lines, curves, and all the different types of translations that come with it. So you might want to stick around for that one. As per how to easily sketch this, well, there might not be an easy way. You could consider looking at the parent function x equals to y squared, and you know that if you were going to sketch that, that would just look like this. So if you then consider using the translation y minus 3 all squared, it means that this graph jumps up, okay, up to the point 3 on the y-axis. So you have this. Okay, so I know the negative seems ironic because minus really should be reducing, isn't it? But what actually happens is that it jumps up. Look, if you do the algebra, you see what I mean. And then when you have a minus in front, it just means that, let me kind of put it down here. So if you have x equals to minus y minus 3 all squared, what happens is it then flips over to the other side. So instead of you to have it here, you would then have it over here. And it crosses your graph at the point -9. This one, if it comes down, well, that's a terrible way to draw it, but hold on there. If I draw this and it comes down here, that will be at 9. Okay, hopefully that makes sense. So I'm just going to clean what I've written so that you can see the proper graph. Yeah, and that is that. And because it fails the vertical line test, you know that that will not be a function. And that brings us to this other one. Yeah, so that is y equals to the root of x, which the graph is very similar to x equals to y squared. And the reason is because if you try to make y the subject of the formula here, you will have y to be equal to plus or minus the root of x. And what we just do is to take out the minus, okay? So instead of having this one for the original x equals to y squared, or if you like, y equals to plus or minus root of x, what we do is we take out the negative part down here. So we no longer will have this, and we just have this bit. Well, it's important to note that helps us to be able to define a function whose inverse is also a function. Whose inverse is also a function. So what you have here is a function whose inverse is also a function. Well, you would understand that better if you consider looking through inverse functions. So this is the graph of y equals to the root of x. Okay, clearly this is a function because if you draw a vertical line, it crosses your curve at only one point. Okay, so it passes the vertical line test, and that means it is a function. That takes us to the next example. Oh, this is interesting. Okay, so if you have this and you want to sketch the graph, you probably want to consider the parent function y equals to x, which travels like so, just right through the middle. Okay, so that's y equals to x. Yeah, it's not perfect, but I'm sure it's something that you will not mind me drawing. So you have y equals to the root of x. Now this essentially ensures that y is always positive, which means that this part that has y to be negative would have to be cleaned out or cut off. Okay, so we bounce it back up here, so we have something that looks like this rather than what we had before. So this line I'm going to clean out, and now I have y equals to the modulus of x. Okay, is this a function? Yes, it is, because it passes the vertical line test. We move to the next example, and this gives us x equals to the modulus of y. Ooh, so how do we consider this? Well, we attempt to sketch again. We have the y-axis and the x-axis again. Ignore my wobbly line. The parent function here will be x equals to y. And that means I draw this across like that. Is meant to pass through the origin. So if it's not, you're going to have to bear with me. There you go. So this one ensures that x is always positive. This part here, okay, ensures that you have x to be negative. So we have to bounce it back. Not up, not that way, because if you drew it that way, you still have x to be negative. This is the negative axis. So you want to bounce it back this way, which ensures that all your x's is positive. And you do not want this part that gives your x to be negative. Okay, so this is your x equals to the modulus of y. The question is this a function? And your answer is as good as mine. No, it is not. If you draw a vertical line, it crosses your graph at 2 points. So it is not a function. Okay. Do we have any more examples? No, I think we've treated everything we can. Hopefully those will be enough for you to totally understand what functions are and the ones that are not function or that are not functions. I've got one last example though, and this one is a word problem. And the question says, the set of x coordinates of the ordered pairs of a relation is called, the set of x coordinates of the ordered pairs of a relation is called, and the answer will be C, which is domain. I hope you got that right, and I hope this video has been really helpful.